Hello students, welcome back to chemistry online class. Today I'm going to treat a topic which is empirical formulae, and I've made a video on empirical formulae and molecular formulae, differentiating between the two, but this time around we are working on the calculation. So empirical formulae shows the simplest ratio of atoms of elements, that is each atoms of elements that makes up a compound, while molecular formulae shows the exact number of atoms of each element in a compound. Now let's consider this question. Analysis of a sample of an organic compound showed it to contain 39.9% carbon, 6.9% hydrogen, and 53.2% oxygen. Calculate the empirical formulae. Now, if the relative molecular mass is 60, what is the molecular formulae of the compound? From the empirical formulae that we are going to work out now, we can also deduce the molecular formulae. So let's start. The compound contains carbon, hydrogen, and oxygen, and their atomic masses, or percentage abundance. That's the first step, to write their percentage abundance here. For carbon, it is 39.9. For hydrogen, we have 6.9, and for oxygen, 53.2%. Now, in case you are not given the third abundance of the percentage abundance of the third element, you can add the two together and subtract from 100 to give you your answer. But if you add all this together, it will still add up to 100%. Now the next step is to divide the percentage abundance by of each element by their atomic mass. Atomic mass, which is also known as the mass number, has been given in the question. Carbon is 12, so we have 39.9 divided by 12, 6.9 divided by 1, because hydrogen is 1, that's the atomic mass or mass number. Then oxygen is 53.2 divided by 16. So after dividing this, we end up getting 3.33, then we have 6.9, and then 3.33. Now the next step is to divide by the least. We check the least value here from what we have here now. The least value is 3.33. So we are divide by the least value. So we have 3.33 divided by, all right, let's do that here. 3.33, 3.33, 3.33. Now this will give us 1, while this will be 2, roughly 2 or 2.0 plus, and this is also 1. So from that, we have the empirical formula to be carbon as 1. It shows the simplest ratio of the atom. Hydrogen, which is the second element, as 2, and oxygen as 1, which can be rewritten as CH2O, because 1 here is we are going to leave it because it's negligible. So from there now we can work out the molecular formulae. Now take note, when you are given molecular formulae, when you are not given molecular formulae, maybe you are given the vapor density, you can multiply vapor density by 2 to get molecular mass. It is that molecular mass that you will use to get the molecular formulae. So if you are given only molecular mass directly, then use it. So let's go. The whole compound is a CH2O. Equate everything to N to the power, as in N should be outside. N should be outside, representing unknown number of carbon, hydrogen, and oxygen. That will give us the exact number of atoms of each element in that compound, and then we get the exact formula of the compound. So everything is equal to 60, because it said if the relative molecular mass of the compound is 60. So let's open the bracket. Carbon here, atomic mass is 12. So we have 12 plus hydrogen multiplied by 2 plus 16 of oxygen, since we have only 1 atom of oxygen here. And we have hydrogen, 2 atoms. That's why we multiply by 2. Everything in bracket N outside equals to 60. So we have 12 plus 2 plus 16, all bracket N equals to 60. So therefore we have 30N equals to 60. Now the next thing is to divide both sides by 30. So we have N as 2. Now from here, now we can get the actual formula So if we have N as 2, so we have CH2N bracket 2 outside to be C2, using 2 to multiply. Where you have N, you substitute the value of 2. So we have C2H4O2. So the actual formulae, molecular formulae of the compound is C2H4O2. Watch out for more videos on other interesting topics. Thank you. Don't forget to subscribe on my YouTube channel. Subscribe for me. Olabisi Olawoye is the name of my YouTube channel. Thank you.